Do you know that every sugar factory should have a laboratory? If you want to know the function of laboratory in sugar industry, kindly join me in this video and other coming videos that will be about laboratory analysis done in sugar industries. I request you to have a notebook and a pen because what we are going to cover is very essential for you as a food scientist. Sometimes working in sugar laboratory might be a bit risky because chances of being injured are very high. Therefore, you must master every rule and requirement of lab. If you love food science like me, you will not fear to work in the laboratory. By the way, I work in sugar laboratory in one of the best sugar industries in Kenya, so I have experience in what I'm going to share out. Mostly, the analytical procedures used in every sugar factory in the world are uniform because there is an international organization which made and documented those procedures. Laboratory is a room with equipment and chemicals for doing scientific tests. Laboratory testing refers to the process which depends on scientific analysis to identify problems with raw materials, processing line, and final food product. For our case, the raw materials is sugarcane and final product is sugar. These tests provide analytical data on the quality of the product. Since laboratory has hazardous chemicals which may harm those using them, below are some of the rules that people working in lab should observe in order to prevent injuries. Number 1. Wear protective clothing like laboratory coat, safety boots, gloves, and nose masks. Number 2. Do not eat while in the lab. Number 3. When doing any analysis, strictly use the given procedure. Number 4. If you are not sure of procedure of preparing any chemical, please don't prepare it because some chemicals are explosive if they are mixed wrongly. Number 5. Wash your hands thoroughly with soap and water after every analysis. Number 6. In case of any accident, kindly inform the lab in charge. Major role of lab is to ensure that sugar produced is of the best quality, i.e., it meets customer requirements as well as companies' national and international standards. This big role is divided into the following tasks. Number 1 is to identify critical control points which require close monitoring to minimize sugar loss, chemical consumption, and factory maintenance. For example, the pH of extracted juice is one of the critical control points. Number 2 is to set critical limits for each point. Critical limit is a maximum or minimum value which a parameter must be controlled to prevent a problem in factory. For example, the pH of clear juice should be between 7.0 to 7.4. So the critical limit for this juice is 7.0 to 7.4. Number 3 is to establish monitoring procedures. Laboratory staff has to come out with scheduled sequence of measurements to assess whether critical points are under control. Mostly, sugar industries use international prescribed methods of analysis. Number 4 is to establish corrective measures for each point in case the process deviates from the set critical limits. I'll still use the example of the pH of clear juice. In case the pH of clear juice is below 7, the corrective measure will be to increase the dosing of milk of lime to the incoming extracted juice. While if the pH is above 7.4, the dosing of milk of lime is reduced. Number 5 is to analyze all the samples brought in the laboratory. The lab has samplers and the analysts. The work of the samplers is to collect all the samples from every stage of sugarcane processing, while the work of the analyst is to analyze those samples brought in the lab. Number 6 is to record results of every analysis done. Number 7 is to prepare manufacturing reports. Number 8 is to inform operators of sections in case parameter deviate from the critical limit so that they apply corrective measures. Number 9 is to record every stoppage and the reason for each stoppage. Number 10 is to analyze raw materials and chemicals brought from the suppliers. Number 11 is to prepare reagents which are required to do analysis. I've already talked about samplers and sampling, so let's see what sampling is. Sampling refers to selecting a representative group from the population. For example, I have 10 stalks of sugarcane. These 10 stalks will be the population. So in case I don't want to analyze all these 10 stalks, I'll pick a representative of these stalks. I can decide to pick 3 sugarcane. So these 3 sugarcane will be a sample. As I've said, population is the whole of the material whose properties the analyst is trying to obtain the estimate. We have 2 types of samples. Number 1 is spot sample. Spot sample is a single sample collected at one location and one point at a time. For example, if I need spot sample of mixed juice, the sampler will just go and pick at once mixed juice and bring in the lab. Now the second type is composite sample. Composite sample is a sample of material which is obtained by blending 2 or more individual groups. For example, if I need a composite sample of clear juice, the sampler can pick the first sample at 7 AM, put it in the lab, wait for another 2 hours, pick another sample, come and mix with the first sample to make composite sample. Sampling is done frequently to ensure that each step is controlled within the set critical limits. It is difficult to analyze the whole material in the factory because many analytical techniques are, number 1, time consuming. For example, if you want to do the reducing sugars of 50 ml of juice, you will need around 1 hour, 1.5 hours. So what about if you want to analyze the whole juice produced in the factory? Number 2, these methods are expensive. Remember, the equipment used and chemicals used are very costly. Number 3, they are labor intensive. So in case you want to analyze the whole material, you will need more analysts. And finally, these techniques use hazardous chemicals. So the samples brought in the lab cannot be consumed by people again. It's therefore important to select a fraction of the whole material for analysis and assume that its properties are representative of the whole material. The main factors to be considered when taking and storing samples for analysis are: number 1, rinsing container with the material to be sampled first before taking the sample to prevent cross-contamination. Number 2 is to preserve juice and bagasse samples with mercuric iodide or mercury chloride and ammonium respectively to prevent degradation. Number 3 is to use the correct order of sampling. If the laboratory has decided that you sample after 2 hours, you have to follow that order. And finally, ensuring that the sample is a well representative of the whole population. Both sampling and analysis should be accurate and precise to avoid getting wrong results. The table below shows the examples of samples picked at each section of sugar processing. The first section is cane yard. At cane yard, the sample picked is whole cane. Whole cane can be picked at the floor of the cane yard or on tractors. Sometimes the farmer can harvest cane in the field and bring to the lab. The second section is pre-milling. At pre-milling, the sample picked is prepared cane. At milling section, the samples picked are first expressed juice, last expressed juice, mixed juice and bagasse. At juice treatment section, the samples picked are lime juice, clear juice, mud, filtered juice and filter cake. At evaporation section, the sample picked is syrup. At pan boiling section, the samples picked are macecutes A, B and C, grainings, slurry and B seed. At centrifugation section, the samples picked are molasses. Under molasses, we have A heavy, A light, B molasses, and final molasses. Another sample is melt and magma. And at packaging section, which is the last section, the sample picked is final sugar. Finally, let's see the analysis done in sugar industry. I'm just going to highlight this analysis, but in the coming videos, I'll be covering the principle, procedure, and the expected results of each analysis. Number 1 is Holken analysis. Next is Briggs, Paul, and purity. It can be of juices or macerates or molasses. Number 3 is preparation index. Number 4 is moisture content. Number 5 is reducing sugars in juices, sugar, and molasses. Next is total reducing sugars in final molasses. Next is calcium oxide in final molasses and juices. Next is conductivity of sugar and final molasses. Next is sugar color. Next is suspended solids in mixed juice and final sugar. Next is fiber percent cane. Next is phosphates in mixed juice. Next is the pH of juices. Next is density of molasses. Next is sludge analysis in molasses, and finally sugar crystal size distribution. Thank you very much for watching my video. If you have not yet subscribed to my YouTube channel, I advise you to subscribe so that you can get more educative videos on food science and technology. See you in the next video. Bye!